We want to use the arc length formula to try to figure out what is the circumference of a circle. So let's see the equation of a circle and see if we can set up an equation to find the arc length. That will tell us what the circumference of the circle should be. Let's see the problem. So I want to figure out what is the circumference of a circle, right? So the circle that I am going to use is going to be a circle of radius 1. Right, so this is a circle of radius 1, and I know that the equation for this circle is usually given by x squared plus y squared equals 1 squared, or just 1. Right, so this integral would be pretty hard to take if I didn't sort of restrict myself, but I know that circles are really stinking symmetric. So what I'm actually going to do is just focus on what's happening in the first quadrant. Right, and so here my equation is y is equal to the square root of 1 minus x squared. Right, and then I'm going to need to multiply my answer by 4 to figure out what the actual circumference of the circle is, because if I figure out what is this length, it's the same length in all 4 of the quadrants, so I multiply my answer by 4. All right, so what am I going to do? Well, I'm going to use the arc length formula to figure out what is the circumference of this circle. All right, so the arc length formula says that I integrate over, well, what are my x's going from? X's are going from 0 to 1. So arc length is the integral from 0 to 1 of the square root of 1 plus dy dx squared times dx. All right, so I need to figure out what is dy dx, and then when I get done with this whole problem, I'm going to multiply my arc length by 4 to get the arc length of the whole circle. Right, so this is the whole circle. Okay, so what is dy dx? Right, so dy dx, in this case, I take the derivative of y with respect to x. So I get 1/2 times 1 minus x squared to the negative 1/2, multiply by the derivative of the inside function, and that's negative 2x using the chain rule. Right, so this 2 and this 1/2 are going to cancel, and so what I have left is minus x over the square root of 1 minus x squared. Right, so this is my dy dx, and I'm going to go ahead and plug that in into my arc length function right here. All right. So now the arc length is 4 times the integral from 0 to 1, the square root of 1 plus the dy dx that I just found, negative x over the square root of 1 minus x squared. I'm going to square this, and then I have dx, right? So this is the formula that I want to calculate. Okay, so let's just go ahead and start attacking this with algebra. So far, it looks pretty complicated, and I'm not sure I'm going to be able to evaluate it, but we will press on. So I have 4 times the integral from 0 to 1. This is the square root of 1 plus negative x squared is just x squared. And in the bottom, square root of 1 minus x squared squared, everybody's in the first quadrant, so everything's positive, life is feeling pretty good, is just 1 minus x squared, so dx. Then I probably want to combine these all into one fraction. So this is the square root of, what's my common denominator? Well, the denominator here is 1 minus x squared. So I have 1 minus x squared over 1 minus x squared plus x squared over 1 minus x squared dx. And then when I combine these two fractions into one, this negative x squared and this positive x squared are going to cancel. So what I have is 4 times the integral from 0 to 1, square root of 1 over 1 minus x squared dx. Well, now I can actually take the square root of the top and the bottom separately, right? So the square root of 1 is just 1. So what I'm left with is 4 times the integral from 0 to 1 over 1 over the square root of 1 minus x squared dx. Right? So taking the square root of the top, square root of 1 is 1. Taking the square root of the bottom is square root of 1 minus x squared. Right? So this is what I'm looking at. And now I think to myself, gee, that looks really familiar from something that I did a long time ago and maybe tried to forget. This is actually the derivative of the arcsine. So what I have here is 4 times the arcsine of x, and I'm going to evaluate this from 0 to 1, right? So if you're not convinced that arcsine is an antiderivative for this, just take the derivative of arcsine. You should get back exactly this function right here. Okay, so then let's evaluate what we're getting here. So I have 4 times the arcsine of x, so I'm going to evaluate this from 1 to 0. So 4 times the arcsine of 1 minus 4 times the arcsine of 0. And when I evaluate arcsine, I have to think what value of sine would give me this thing, right? And so the arcsine of 1 is pi over 2. So I get 4 times pi over 2. And the arcsine of 0, well, the sine of 0 is 0, so the arcsine of 0 is also 0. So I have 4 times 0, which means the answer that I'm getting is 4 times pi over 2, also known as 2 pi. And lo and behold, that's exactly what I expect to get when I calculate the circumference of a circle with radius 1. That was great. We got exactly the answer we expected. I challenge you to try to do the problem yourself with a circle with a different radius. See if you get the same problem or the same answer that you should get if you just calculate the circumference. So, would we ever do this in real life? Probably not. It's a good example to help us practice some more with the arc length formula, but when you encounter a circle in the wild, you probably should just go ahead and use the circumference formula that you know and love. If you have any questions about this, make sure you post it on the forum, and good luck.